Hey students, I'm so glad you are watching this video lesson today. Okay, so let me give you an introduction to the lesson for today. Yesterday, or the previous lesson was over conditional statements. Okay, so in conditional statements, you saw a statement in which you introduce if and then. And the point is you can argue the truth value of a conditional statement. If you just make a statement and don't have if and then it's hard to make an argument as to whether what you're saying is true or false. So today we're moving to another lesson, which is biconditionals. Biconditionals have if and only if, and that's what I'm going to explain on this video today, and I'm going to try to make it as simple as possible so that you're able to follow the lesson and also be able to successfully complete today's assignment. Okay, so let's go ahead and get started. All right, so note 2-3, biconditional statements. Okay, so biconditional statements have if and only if, and you'll see how if and only if is introduced in a biconditional statement. So let's see here real quick. Okay, so biconditionals, you'll see if and only if, and it can only be done when a conditional and its converse are both true. So if the conditional is false, then we can't do biconditional. If the converse is false, we can't do the biconditional. So they both have to be true. Okay, they have to be true statements or true conjectures. So let's see here. Example: congruent angles have the same measure. And as you can, if you remember this from the previous lesson, this is not a conditional statement. It is a statement, but it's not a conditional statement. So that means we don't have room here to argue whether this is a true or false conjecture. Okay, so let's turn this into a conditional statement. So what would the conditional statement look like? Try to remember from yesterday, and then try to write it down, and then see if we get the same statement. So the conditional statement for this one would say if, and I'm underlining if from yesterday, if angles are congruent. Okay, so if angles are congruent, then they have the same measure. So now this is a conditional statement, and you and I can disagree as to whether this is a true statement or a false statement. Okay, so there's the conditional. What about the converse? How would you write the converse on this one? Don't forget, the converse is going to, just as a reminder, this is P, this is the hypothesis, and this is the conclusion. So P is the hypothesis, Q is the conclusion, and the converse is going to do what to the conditional? You guys remember that? It's just going to switch them. Okay, so it's going to be backwards. So then we would say if angles have the same measure, if angles have the same measure, then what? Then they are congruent. Okay, and again, I'm going to underline if and then. You don't have to do this. I'm just trying to help you remember from yesterday. Now let's discuss the truth value of this one here. If angles are congruent, then they have the same measure. Well, the definition of congruent is that they are equal. So this one is true. So far, so good. The second one, if angles have the same measure, then they are congruent. Well, this is also true, right? So once we see that the conditional statement and its converse are truth, then we can proceed to write the biconditional. Okay, so the biconditional is going to say the following. And notice that I already have if and only if here. Okay, so I don't have then, it's going to be if and only if. So I'm going to do the first part. Okay, so I'm going to say angles are congruent. So angles, okay, angles are congruent if and only if, so there's the biconditional part, if and only if they have the same measure. So I hope you can see the difference here. I turned these two, this conditional statement and this converse, into a biconditional, and I just introduced if and only if on the statement. Okay, so let's continue with the lesson. So what are the two conditionals that form this biconditional? So I'm going to take you back to this one here. These are two conditional statements, okay? So notice how we were given just a statement. We turned that statement into a conditional statement, and then we wrote its converse, and then we did the biconditional, but they both have to be true. They both had to be true so that we could do the biconditional. So now we are going from here, once we have the conditional, we are going to break it apart into its two conditional statements. So this is a backwards problem. So watch what the problem says. So this one says two numbers are reciprocals if and only if their product is 1. So there is the biconditional. How do we know it's a biconditional? Again, I'm going to underline this part, if and only if. That's how I know it's a biconditional. So it's not just a conditional statement, okay? So the question is, what are the two conditionals that make up this biconditional? So I'm going to give you the first one. Okay, so conditional 1. I'm going to introduce if, okay, at the beginning. Okay, so that's the difference. Instead of being in the middle, now it's going to be in the beginning. So this will be if, okay, so if what? If two, okay, so if two numbers are reciprocals, okay, if two numbers are reciprocals, I'm going to do now the then part. Then their product is 1. Okay, so there's the first conditional. So notice I have, let's say this is the converse. It doesn't matter which one it is. Okay, so let's say this is the conditional statement. Now to get the other one, I'm going to do the converse of this one. Okay, so the second conditional from here, from this biconditional, is going to be if. Okay, so again, you always have if, because this is a conditional statement. Okay, if two numbers have, okay, so if two numbers have a product of 1, here comes the then part. Then what? Then they are reciprocals. Okay, so that's how you undo a biconditional, by writing its two conditional statements. All right, I'll talk to you soon. Thank you for watching. Bye.